a Q&A window. A good idea of how all of them fit together and how all of them can help add productivity and power into how you're building and shipping cloud applications. And as mentioned, we'll be answering questions throughout and have some dedicated time at the end to answer questions as well. So to start with, let's think about event-driven applications and what it means. And from a basic standpoint, I just wanted to pull this definition up. Event-driven architectures is almost the next iteration or an even more granular implementation of microservices. In this case, what you're writing is your code or your business logic to execute in response to events. And this is almost a natural way of thinking about your business logic or your code, because often when you think about a requirement, it really is this event-driven nature that you think about it. For example, hey, we got a new customer. Whenever we get a new customer, we want to send them a welcome email. We want to add them to our CRM database. We want to add them to our Analytics Insights database. These are all different capabilities that I want to have happen as a result of something like adding a customer or having a sale or it being Friday at 5 o'clock p.m. The type of event can be extremely flexible. And what's important for you to think about is that event-driven architectures is building your application as different pieces that are both publishing events and pieces that can respond to events to execute some type of business logic. Now, one of the benefits of event-driven architectures that you'll even be able to see as we go throughout the presentation today, that these event-driven architectures are extremely loosely coupled and well distributed. They really are built for cloud-native workloads where you might have an application that spans many data centers across the globe, and you want to have the flexibility and the agility to add and remove capabilities very rapidly. We need to write applications in a way that enable us to respond to the speed at which we're getting business requirements, and event-driven architectures give us the tools to do that. Let me just illustrate this with a simple example of an event-driven architecture. This is one of the most basic ones I like to think about. I almost kind of teased it a second ago, which is, let's say that there's a business event in that somebody has completed a purchase. So maybe there's an e-commerce site, a purchase has been completed, and as a result of that purchase, our application somewhere is going to emit an event. Now, when it emits an event, it doesn't necessarily even know what's on the other side of that event. It just knows a purchase was completed. And it's up to me to then subscribe other pieces of my application to that event. What else might care that a purchase was just completed? Well, I might have a piece of business logic which is in charge of generating shipments. It's going to subscribe to that event, potentially generate some metadata around the shipment, and make sure that the product ends up getting shipped to the customer. I might have something like storing a transaction in a database. In this case, I might have some piece of code that's going to listen to that event, take the data, and store it in a database. And then a few months later, I might have some people from the business who come up and say, hey, I have enough data here that's being stored. Our business is growing fast enough. Maybe I actually want to be able to give recommendations to the customer, help them understand what else they might be interested in. So without having to make any changes to these existing aspects, I could then add a new event consumer that does something like email recommendations. Hey, you bought a hammer, you might also be interested in nails. All of these pieces can be decoupled from one another. They could scale independently as needed, and I can add new additional capabilities whenever I need to. So this is some of the benefits of this event-driven architecture. All right, so that's going to bring us into event-driven and serverless, because these two really meld well together. And I'm going to give a little bit of an introduction into serverless, so keep the event-driven architecture in the back of your mind. Serverless is very related to it. So serverless is a way to build and deploy applications where you aren't thinking about the servers at all. They're completely abstracted away from you. In Azure, the hero serverless service is called Azure Functions. I'm going to show it in just a second. And it lets you take advantage of event-driven architectures by saying, hey, here's the code I want to run. Here's the code I want to execute on something like an order being completed. You publish it to the cloud, and everything else is automatically managed for you. You're not building or deploying any servers. You're not having to worry about scale, and you only pay for what you use. So if I deploy an event-driven app using serverless Azure Functions, and let's say nobody makes a purchase in that day, I would never pay for that Azure function because it never got triggered. There was never an event to let my code know that it needs to run. So this is a little bit of what serverless does. It's nice because I'm not having to manage or deal with the complexity of server infrastructure. So some of the benefits of it are a little bit obvious as well. What this allows my teams and organizations to do is focus on solving their business problems, rather than wanting to do something like build that recommendation email where maybe I'm going to send some product recommendations and have to spend so much time focusing on, well, how am I going to get the infrastructure ready to go? How am I going to make sure that this can scale if I have a massive promotion and lots of people are making purchases? How do I make sure these servers stay secured and up to date? That's all taken care of for me, so my team just starts writing that business logic. They're focusing on the problem that they're solving. The sentiment that I hear time and time again for customers of things like Azure Functions is that it enables them to build applications and have faster time to market. Something along the lines of, hey, we wanted to build a new capability. We were able to ship it in weeks instead of months. And you also get a lot of flexibility as well. You're able to add and remove components using a variety of different languages, using a variety of different event sources, all with things like Azure Functions. And Azure Functions, being event-driven, it comes with its own event-driven programming model, out of the box, ready to go. So you can tell it the event sources you care about. Hey, I want to run this code in response to a change in my Cosmos DB database. Or I want to run this event whenever an item gets dropped in a queue, or whenever someone makes an HTTP request to this API. I can start leveraging those triggers, taking advantage of rich local tooling, CI/CD, monitoring. It all comes out of the box. So Azure Functions really is a fantastic fit for these event-driven workloads. Now, some of the places we see customers using Azure Functions, I've listed the top scenarios that I'm seeing them being used for. Web application backends is a really big one. Something like a serverless API, where the event is somebody visiting your web page or maybe clicking a part of the web page. That should trigger some code that does something, right? I want to sign up for a newsletter on the website. That could call a backend that then adds me to the list or sends me a notification. Similar with mobile applications. As your mobile application grows, serverless enables you to scale that code powering the mobile application in the cloud, completely event-driven. IoT for IoT devices, sending telemetry to the cloud, processing it in real time processing from bots, streams, files. These are all very common. And finally, automation is really big. An event very often is something like, hey, it's the end of the month, it's the end of the week, it's the end of the day. Do I want to go shut down all my virtual machines? Do I want to go index this database? Do I want to check whenever somebody deploys something into the cloud, run some compliance checks, make sure that everything was according to the rules that I've set up in my business? These are all the types of events that you might be interested in that Azure Functions can connect to out of the box and natively. And again, I'm going to show you that in just a second, so that will hopefully help it come together and seeing how Azure Functions is an event-driven programming model, and you can also host these functions in the cloud in a serverless way. Now, just one more example here of Azure Functions and event-driven. This is an existing customer that we've worked with, Johnson Controls. They wanted a way to be able to manage these different IoT devices. And for their initial test, they simulated 20,000 concurrently connected IoT devices. The event-driven architecture worked very well in IoT because as new devices came online, those devices are emitting events. An event like, hey, the temperature has changed, or somebody sets a new temperature, or whatever else it might be. All of these pieces of data, all of these pieces of insights are events that are being published to the cloud. And responding to each of those events are Azure Functions. Azure Functions that can register devices, Azure Functions that can pair devices, Azure Functions that can update settings or update temperature. So you can see here just an example of how you take something like an IoT device, you start emitting those events, and event-driven architectures allow you to respond to those events with the logic that you care about. You can make changes to each one of those event consumers independently. You can start to add new event consumers flexibly as well. So this is very decoupled. It scales extremely well, and it gives me a lot of flexibility as I'm thinking about solving some cloud-native applications. So let's go ahead now and take a look at Azure Functions, because it's important to think about Azure Functions before we move into things like containers and Kubernetes. So we've talked a little bit about Azure Functions role. Let me go ahead now, and I'm going to share my screen. And we're going to walk through creating an Azure function, in this case inside of Visual Studio Code, but we also have tooling for Visual Studio, IntelliJ, Eclipse, but let's just keep it here in Visual Studio Code for now. So I'm going to go ahead and choose, I've added this Azure Functions extension to Visual Studio Code, and here I can create a brand new Azure Functions project. Now I'm just going to go ahead here and create one called Webinar. And when I use Azure Functions, I'm going to get this nice integrated tooling experience. And the first thing it wants to know is what language do I want to have my business logic running in? It could be PowerShell, Java, C#, TypeScript, JavaScript. Let's just go ahead and use Python. I'm going to have a simple Python script run in response to an event. You can see here, this is just a few of the event sources that I could select from. Things like an event, something happens in a storage account, someone uploaded some artifacts, a database, data stream, queues, timers, HTTP. In this case, I have a queue. I have a queue in the cloud that has a work item, and I want to run this code whenever something gets dropped in a queue. I'll give this function a name. Let's go ahead and select our storage account. I have one right here ready to go. And the name of the queue that I'm using here is actually called queue. All right, let's go ahead and finish configuring this. I'll zoom out a little bit. And Visual Studio Code is now going to set up for me my project, ready to go, and process these queue messages. So without me having to do much of anything, let's see once this generates and refreshes. Here now is my Python Azure function. You'll notice here there's not a whole lot of code that I have to manage. This is the whole function. It looks very much just like a simple console application. But instead of passing an argument, it's passing in a queue message. And this is where now I could write and describe whatever logic I wanted to have happen whenever a message gets dropped in this queue. So my queue message processing. I'm not going to spend the time to actually write the code here. But to show you, let's go ahead now. I'll go ahead and do something like set a breakpoint. Let's choose to start debugging this function. This is going to use the tooling to spin up my Azure Function app locally on my machine. It's going to connect to the storage account. In fact, I'll show you right now. Here's the storage account. Here's the queue, right? So I've got my storage account I'm listening to. I've got my queue here ready to go. And in this case, it's now running and waiting. So let's add a queue message. Let's say, hello, functions, and say, OK. Now, as soon as I drop that queue message in, you'll notice my breakpoint got fired. The event happened. An item got dropped in the queue. So now I'm debugging this script that I have running. If I actually had logic that I wanted to check, I could. In this case, I can just see that the message is there. Everything's working nicely. Somewhere in here, I'm a little bit zoomed in here, so you can't read it. But if I actually look down here at the execution log, you can see that it emitted the telemetry. It said hello functions right there. So the event happened, the event fired, and so my app worked great. Now at this point, once I get my code ready to run the way I want it to, connected to the event source that I care about, here's where traditionally I could come in and I could publish this now to run in the cloud. And now it could run in serverless Azure Functions so that whenever a queue message gets triggered, this function would run and I only pay for that compute. Okay, so that's Azure Function. We'll come back here in a little bit and we'll take some time now and talk about some other ways that you can take advantage of event-driven compute and these ways of writing in a productive environment like Azure Functions. So that actually takes us to another world. So we've talked about event-driven. We've talked about these event-driven functions and Azure Functions specifically. Now, how do we bring that together with this world of containers and Kubernetes? Because a lot of businesses are finding extreme value in offerings like Kubernetes, where I can write an orchestrator to manage my application. So let's take some time to talk about what that looks like now. So to begin with, we've talked about apps already. Now let's talk some about containers. I'll show you this in a second, but containers are just an industry standard way to package up your application code and their dependencies. So in this case, I visualized a container. Each container is like a little dot. So I might have 3 containers that make up my app. Maybe one container is running the front end, one container is running some database logic, and so forth. I can take those application pieces and I can package them up in a container. Okay, so containers is just a way for me to package, distribute my app. It comes with all of the dependencies, whether that's operating system dependencies, runtime dependencies. So now I can take my app and run it anywhere. So for example, when I showed you a second ago writing an Azure function, I wrote that on my Mac in Python. I could take that, put it in a container, go to a Windows machine that doesn't even have Python installed, run that exact same container, and my code's going to execute the same way that it just ran on my laptop in this case. So that's what containers let me do. But rather than just taking a container and running it on like a single Windows machine, most likely what's going to happen is that when I want to run in production, I actually want to run on a number of machines. So this is where Kubernetes comes in. Kubernetes is a layer on top of a number of different machines, or nodes in this case, as you see from the graph. Maybe I have like 6, 7, 8, 100 servers. And rather than having to remote in or SSH in to each one of those 100 servers, start my container, make sure that it's running, make sure that it's healthy, it's a lot of overhead. What I'd rather do is treat this like a single entity, a single layer. I really want it to feel like one machine, and that's what Kubernetes lets me do. And how Kubernetes manages this is that you give it your app, you give it your containers, and it will then scale them and run them reliably across your entire cluster, across all of the virtual machines, all of the nodes that you are managing. It does this in a very seamless way. That's why a lot of people are getting very excited about Kubernetes. They can take these applications, they need to run across multiple regions, they need to run in a highly available way across a number of different machines, but manage it from a single spot. That's what Kubernetes lets me do. So it's going to scale those containers as needed, making sure that they're running and available. So now that we understand a little bit about containers and Kubernetes, let's bring this back to event-driven. Because what I want to happen with event-driven containers is I want to be able to publish some service. Maybe that's one or many containers, like my e-commerce site. That site needs to be able to emit events. And based on those events, I want to make sure that I can subscribe or listen to those services as they're being published. Now, this is what I want to build, but out of the box, this might not actually be a super natural fit for Kubernetes. There's actually a few challenges that come when you want to do event-driven in Kubernetes. So the first one, if you think back to that chart where those containers were running across the different nodes, the way that Kubernetes decides how to scale your different containers is based on CPU and memory. It's trying to guess how many events are coming in by how much CPU and memory are being consumed. But Kubernetes actually doesn't know anything about your event sources. So if you want to do an event-driven function, like I just showed you in Azure Functions, listening on a queue, Kubernetes doesn't know about your queue. It doesn't know if the queue is empty or full or just has a few items. It's just going to have to guess based on memory and CPU. The other challenge here is that you might have a number of different event sources. I showed you that list in Azure Functions. There were like 10 different sources between databases, storage, queues, topics, event streams. What happens when I have events that are happening across all those different event sources? How do I make it so that my application developers are able to write against those event sources, bring those events in from a number of sources into their Kubernetes workloads, into their containers? And then finally, even if I sometimes have the code, that logic can be challenging. Event streams is a good example. Things like Azure Event Hubs or Kafka, they have concepts like partition. They have concepts like consumer groups. As I build scalable applications that need to scale to all of those different events, I need some kind of coordination. I need to make sure that I'm reading from the right partitions, that I'm reading from the right consumer groups. That can be some logic that you might not want to deal with. And I'm bringing these challenges because actually what we're providing now through Azure and supported tooling is the ability to overcome each one of these challenges with a combination of the Azure Functions programming model that I showed just a second ago, and this new set of capabilities called Kata. So Kata is Kubernetes-based event-driven auto-scaling. You can think of this as a way for Kubernetes to become aware of your event sources. Now Kubernetes can know about your queue. Now Kubernetes can know about your event stream so that as you're building event-driven architectures, Kubernetes can be proactively aware and scaling as needed as events are coming in. Now Kata is completely open source. Microsoft has actually built this in partnership with Red Hat, and it's available for the entire community to contribute, add event sources, and help us build better event-driven capabilities into Kubernetes. One of the other good things about Kata is that it actually works natively with Azure Functions. So you can take Azure Functions, including that Azure function that I just wrote a second ago. You can now deploy it in a container to Kubernetes and have it scale and run and be managed in a very similar way to the way that it would scale and run in the Azure cloud. So So this gives you flexibility to choose exactly where or how you want to run your event-driven functions, maybe in the context of Kubernetes, maybe on premises, maybe in Azure, maybe somewhere else. It's up to you. Kata lets you scale your code to 0 on no events, so that if no events are happening for a specific piece of code, that code's not running anywhere. It's not consuming any resources. But if the opposite happens, if thousands of events comes in, Kata enables your application to scale to meet those thousands of events. And really, for Azure Functions, if you think about this event-driven programming model, Kata means that you're writing the same app, you're using the same tools, Visual Studio Code. You could take any new or existing app, but have flexible hosting to run exactly where you want to run. There's a link here to the repo where you can check that out on GitHub if you're interested to learn more or follow some samples. But let's go ahead now and give you an example of Kata. Now, for this first example, I'm actually not going to use Azure Functions. I'm just going to show you how Kata can make you aware of your event sources, even for things that aren't Azure Functions. In fact, in this case, what I'm showing you now is a .NET app. This is a very simple .NET console app that cares about receiving messages from a service bus queue. So in this case, I have events that are being published, and the event broker is a service bus queue, a different type of queue. And what I really want this container to do is pull down those messages. Anytime there's a new message on that queue, you see I had to write a bit of logic here to know how to talk to the event source. That's something I didn't have to do with Azure Functions because it just came with knowledge of those event sources. But here I've just written a few lines of code, nothing crazy, to say, hey, whenever a new message happens, process the message, and it's going to write this log message right here to say, hey, something new has happened in Service Bus. Now I could run this here locally on my machine or in Docker, and that's fine. But what I really want to do is I want to publish this as part of my application into Kubernetes. And for that, I'm going to use Kata. All right, so the first thing I want to show you, if I open up my command line here, is that here in Kubernetes, I'm going to use the Kubernetes command line, which is called kubectl or kubectl, to actually interact with my Kubernetes cluster. In this case, I have one already deployed using Azure's Kubernetes service. But here, I actually see what's been deployed already. I don't have anything that's been deployed. No resources are found. I haven't deployed anything yet. Now, that's actually not entirely true because I have done one thing, which is that I've installed Kata. So I can install Kata through supported tooling like Helm or the Azure Functions tooling. And so you'll actually see here that I do have one thing that's running, and that's Kata. Kata now is bringing knowledge of event sources. It's bringing knowledge of, this case, my service bus into Kubernetes so that when I want to deploy something like this app, my Kubernetes cluster will know about the event source, okay? So let's go ahead and do that now. I've already taken the time. I used Visual Studio tooling to generate a Docker file so that I can now package up this .NET app into a version that will run this service bus receiver with all the information that it needs. And the last thing that I'm actually going to use here that I actually think I do, let's open this up so that you can see it, is the deployment file. So this is a Kubernetes deployment. I wrote this one manually by hand, but we have tooling that can generate this for you. I'm just going to show you, this is what I'm going to tell Kubernetes about. I'm going to tell it a secret. This is a good secret about my service bus connection string so that Kubernetes knows how to authenticate and talk to my service bus account. This is what's called a deployment. This is how I actually give Kubernetes my app. In this case, I'm going to give it my service bus console container. So that container that I wrote, I said, that's the app that I want you to run. And the last piece here, this is part of Kata. This is how I tell Kubernetes about the event source that I care about. So I'm deploying this special thing called a scaled object into Kubernetes. You'll see this is something specific to Kata. And in that scaled object, I'm saying, hey, I want you to listen to this service bus. So I care about a service bus. The connection string is here in that secret. The queue that I want you to listen to is called queue. And I want you to add a new container whenever there's a queue length of 1 or more. And I also have some other options here. I can choose how frequently to check the queue. I can tell how frequently to scale down the queue. I can set minimums and maximums here as well. But for all you really need to know about is that here is the data that I'm going to tell Kubernetes about so it knows about my service bus container. So now I'm going to use the Kubernetes tooling, and I'm going to apply that deployment. So I'm going to take that information. I'm actually going to send it to Kubernetes. You can say it did that. It took my secret. It got my app. and it took that scaled object definition. And now if I come in here and I say, look at the deployment, you'll see I have my service bus console that's been deployed, but here's the cool part, it's actually at 0. It's not running anywhere. It's not taking any compute. And that's because my queue is actually empty. So what I want to show now is I'm going to change this view a little bit. I'm going to watch the containers that Kubernetes has. You'll see right now there's no containers running. And what I'm going to do is I'm going to take that queue, which is empty right now. Let's go ahead and publish an event to it. So rather than saying hello world, let's go ahead and say hello Kata. And as soon as I publish that event, let's switch back over here. As soon as a message got sent, you'll notice that my Kubernetes cluster sees that there's now an event ready to go. And so it has spun up for me a container. In this case, it only needed one because there's not a whole bunch. So now it is spinning up my .NET app, which is running. It consumes the message. And in fact, here, because I set such an aggressive cooldown, as soon as that message is gone, it's going to scale that container back down to 0. So here I've been able to write an event-driven app. In this case, it's a service bus .NET app, which whenever I add a new message, it's going to spin up, run the container, and then spin it back down. It's super event-driven. It only takes compute when it needs it, and it's always monitoring that queue. Now, I don't have this here, but if I was to publish, let's say, thousands of messages to this queue, you wouldn't see it just add one container. You'd actually see that it would start to add multiple containers, that it would continue to scale and scale and scale to make sure that I had the resources that we needed. So that's an example of Kata in action, in this case with just a .NET container, where I had to take care of writing the code of how to talk to Service Bus. Now, this one, don't worry if you don't fully understand how this one works, but I did want to take some time to explain to you how Kata is working behind the scenes. So when I was running Kata, when I showed that first screen and you saw that I had Kata there listening, it kind of is doing 3 separate roles. The first is that it's what's called a metrics adapter that hooks into the way that Kubernetes scales, where it's going to feed data about how long the queue is, how many events are coming in, so that Kubernetes can scale appropriately. Maybe that's scaling to 1, maybe that's scaling to 1,000. But in this case, you're going to be scaling based on the actual event source, not just based on CPU and memory. There's the thing called the controller. That's what's monitoring and saying, hey, Jeff just deployed a Service Bus console app. I noticed that that got deployed. I'm going to start watching it. That's all logic in the controller. And then finally, there's a number of different scalers. Scalers has the event-specific logic. So in this case, there's a scaler for Azure Service Bus. Kata also has scalers for Kafka, for RabbitMQ, for Azure Storage Queues, and many more that are being lit up every single week. In fact, right now there's a pull request open for AWS SQS queues so that those can scale within Kubernetes in the same way, event-driven, to let your pods know, to let your pods spin up so that they can then process the message. So Kata it's very lightweight. It has no dependencies. You can install it in just a single command onto any Kubernetes cluster, and it will start bringing in that intelligence and the knowledge of your event sources directly into your Kubernetes cluster. So the next thing I want to show this bringing it all together. And to do that, let me go ahead now, and I'm going to show you that Azure function that I was looking at just a few minutes ago. Let me go ahead now and share my screen again. Okay, so let's come back here to our first Azure function. This was the one we started with, if you remember. It's a Python function. You'll notice in this case, I didn't have to write as much code as I did in the .NET one. That's because I'm using Azure Functions. If I use the Azure Functions programming model, even if I was to create something here to trigger on a service bus queue, now I don't have to worry about writing that event processing logic. I don't have to worry about the complexity of how that connects together at scale. I just wrote my simple little script here. Now, in this case, I do want to run this inside of Kata. So to do that, let's go ahead, and I'm going to run a few simple commands as part of our Azure Functions tooling. So the first one here, here's my directory. Everything looks good. So let's go ahead and do a Docker container. That's the first thing that I need. So I'm going to say, look at this project and generate for me a Docker container. So I went ahead and run that command. You'll see it said it's writing a Docker file. I can actually come here now and see it. This is the Docker file that it just generated. It's saying this is a Python Azure function. I can now take this Docker file. I could really run it anywhere. I could run this on my laptop. I could run it on premises. I could run it wherever I want. But where I really want this to run is inside of Kata, inside of Kubernetes. So I'm going to do one more command here, which is func Kubernetes deploy. And this is integrated with the Azure Functions tooling. I'm saying, hey, I'll push enter here so it starts deploying it, and I'll explain it while it deploys. I'm saying, hey, call this my queue function. I tell it my Docker registry, which is Jeff Holland in this case. That's my Docker registry name. I'm telling it to check the queue every 3 seconds, cool down after 5 seconds. And you'll notice when I pushed enter, here the tooling is doing the work for me. It's packaging this function up into a Docker container. Right now, it's pushing that Docker container up into my registry. And then once that's finished, it's gone ahead and registered the different components with my Kata cluster. So in this case now, if I actually switch back here to this spot again, here if I say Kubernetes get deploy, like I did a second ago, you'll notice now I have two things that are there listings for events. One is my queue function, and one is my service bus console app. Okay, neither of these are running right now because none of them have events. So the last thing I want to show is that I can take my Azure function, I've deployed it here, and now I want it to scale the same way that it does in the Azure Function Service. So let's watch this again. I'm going to watch these pods. But here, I'm actually going to run one more command. Let me see where this one went. Right here. I'm going to run a simple little script, and I'm actually going to publish thousands of messages to this queue that I'm listening to. So let me go ahead and push run here. It's going to publish a few thousand messages to that queue. And while that's publishing, let's switch here, because what I want you to see that is as those messages start getting dropped in from that console app in the other screen, in just a second, you'll see that now those functions are being picked up. So it's creating my container the same way it did before, but what's going to be different here, because I'm actually pushing a bunch and a bunch and a bunch of containers, you're actually going to see that it's going to create a few different instances of that function. It's going to realize that I'm going to need some help because things are going a little bit crazy. So you'll see that actually right now. Now there's 4 containers that are getting spun up across my cluster. Some of them are already running, processing some of those messages. In fact, down here in the bottom window, I'll show you, if I say, hey, get the scaling that's happening right now, what this actually says is that there's 64 messages that haven't been processed right now in my queue. I've told Kubernetes I want to target about 5 messages per instance, so it's taken that math and it's gone ahead and scaled out for me. And if I actually go and refresh this again, you'll see that that number's gone down a little bit. This is actually 500 millis, so those have all been consumed now. And you'll see that it's actually going ahead and terminating. So I know there's a lot there, a few moving parts, but what was important is that I took an Azure function, just as is, I published it to Kubernetes, and when I threw a bunch of load at it, it was able to scale out based on metrics coming from that queue directly. And then eventually, you'll see now after that, I published a few thousand. It didn't take it very long, apparently. It went ahead and processed them all and scaled me back down to 0. So that's an example of bringing everything together. You've got the containers, you've got the Azure functions, you've got Kata, all working together. All right, so all of you now can start taking advantage of event-driven benefits. This enables you to create these highly loosely coupled and distributed apps. If that queue message was being published because a purchase was completed, you can see that I'm able to just add these different consumer types. I could add new capabilities in a very decoupled way, let them scale independently based on their event sources. I can add that event awareness. I can make Kubernetes aware of my event sources with open source technologies like Kata. And if I want to write even less code, if I don't want to have to worry about writing that event consuming code, that's where Azure Functions comes in handy. Azure Functions is also open source. Even if you're not going to run these in Azure Functions, I'd still recommend you using that programming model because it comes with awareness of your event sources. It knows how to handle those event sources at scale. It gives you things like monitoring and tooling out of the box. What's better yet is that you might take some of these functions and run them in Kubernetes today and then realize in a few weeks, you know what, maybe I'm okay actually running this in a fully managed serverless service. You could take those same apps, that same code, and publish it to the Azure cloud to run in the serverless Azure Function Service. So you really get full flexibility here to write these event-driven containerized apps using Kata, Kubernetes, and Azure Functions. So if you want to get started with Azure, there's a few links here that you can follow. The first, if you want to try out Kata, you can follow the link to GitHub where we have the code hosted. We have a number of different samples here. We have weekly community stand-ups if you're interested in contributing with us, partnering with us, adding more capabilities, adding to our backlog as we continue to build out more event-driven capabilities into Kubernetes. I'd recommend the Azure Functions Quick Start here. It actually builds exactly what I just went through. The only difference is instead of Python, I think it uses JavaScript. But it will walk you through step by step, creating your first Azure function, installing Kata on a Kubernetes cluster, running that function, deploying it to Kubernetes, and then watching it scale. We also have samples using RabbitMQ if you want to use different event sources, service bus, and so forth. And then finally, if you just want to get ramped up on Azure Functions and event-driven programming, we have a number of different quick starts, tutorials, even interactive labs that you can go if you go to aka.ms/Azure-Functions. I'd encourage you to check those out as well. It's a great resource to get you started and running everything you need to do to start taking advantage of event-driven applications. The last thing I just want to close with, too, is just that this is a really productive programming model. It's likely different than how you're writing things today. You might think about things a little bit differently. Instead of thinking about these monolithic applications or even these massive REST APIs, event-driven architecture require you to start thinking about what's the event that's happening? What's the actual event that I want to run in response to that? But I challenge you to try it out, test it out in maybe some new projects, maybe try to refactor some existing capabilities that you have, make them event-driven, and see for yourselves if there's any benefits that are there. You could do this with your existing Kubernetes workloads, with new workloads, Azure Function Service, whatever makes the most sense for you. The tools are there, but I'd encourage you to try it out. It's something I've seen a lot of customers who get very excited about. And honestly, this is the direction that cloud computing is going. Event-driven is going to be a key part of infrastructure and architectures moving forward. So it's important to try that out now. So with that now, I'll spend some more time here. We're going to spend the last few minutes just answering some of the questions as you ask them as well. And so, Nick, I'll go ahead and start answering those questions, and I'll turn it back over to you.
All right, great. Thank you so much, Jeff, for that great presentation. And thanks for everyone who has stuck around with us to this point. So as Jeff mentioned, now that we're reaching the end of our time limit here, we'd like to, just as people are leaving, we'd like to just keep this Q&A slide showing. And we will do our best to get to all the questions that have not been answered to this point. And if you have not asked a question yet, you can feel free to do so now. And we will just push all of our answers to everyone